Hi there. I am Easy and welcome to Easy Peasy Learning Aids. In this video, we will look into the topic of computational thinking. Here is the index of everything we will cover in this series. Computational thinking, decomposition, pattern recognition, abstraction, algorithms. Let's discuss about what is computational thinking. Let's see. What is computational thinking? Let's break it into two words: computational and thinking. Computational means using computers to do a specific task. Basically, involving the use of computers and other devices in any manner. Thinking means using thought to reason about something or to find solutions corresponding to a problem. So, computational and thinking together makes computational thinking, which means a set of problem-solving and reasoning methods that are expressed in such a way that a man or a machine can understand and perform them. The process of computational thinking is divided into 4 steps, namely decomposition, pattern recognition, abstraction, and algorithm. Now, let's look into decomposition. The process of breaking down a big, complex, and typical problem into smaller, easier, and more manageable parts is called decomposition. For example, let's say you are having dinner. Generally, you don't go about putting the entire dinner into your mouth in one go. Ha ha ha. Well, that would be very funny if you do so. Okay. Jokes apart. What do? You finish your dinner in portions. That is, you take a mouthful at a time. If you observe, then you might have spotted that you indirectly broke or decomposed the task of finishing dinner into smaller tasks, that is, to take only a mouthful at a time, thereby making it more manageable. Similarly, when you are following the route to a location, you divide the route to left and right turns, straight and curved paths, etc. Now, it's time for pattern recognition. What is pattern recognition? The process of identifying pattern within problems, sharing some common link or similarity, is called pattern recognition. That seems complicated though. Let's take an example to understand this. Have you ever wondered, why do we call lions and tigers the big cats? This is because of the classification of living organisms that exists. During this classification, Carolus Linnaeus made similarities in skeletal structures, adaptation and physical traits as his basis. In simpler words, he spotted a pattern among the animals. On close observation, lions, tigers and cats had many traits in common, forming a pattern. This is how pattern recognition helped in tackling the complex problem of classifying animals into a much manageable task. Now, it's time for abstraction. When you read a chapter from your textbook, you always highlight and make notes of only the important points, rather than the whole chapter. This is called abstraction. Abstraction is the method of focusing only on the important points and eliminating the rest of the data. This helps us to create a model of the problem that we are trying to solve. Now we are at the last component: algorithms. The step-by-step instructions given for solving a problem is called algorithm. The process of writing an algorithm is called Algorithm writing. For example, let's write an algorithm for preparing a bowl of instant noodles. First step is to buy a packet of instant noodles. Step 2. Pour 1 cup of water into a wok. Step 3. Bring this water to a boil. Step 4. Add the noodles and the seasoning. Step 5. Cook it on medium flame for 2 minutes. Step 6. Serve it hot and enjoy your food. Though we wrote the previous algorithm in simple English sentences, it is important to note that algorithms are always expressed in the form of flowcharts or pseudocodes. Since, as discussed earlier, computational thinking is all about expressing the solution in a manner that both a man and a machine can understand it. And probably, a machine isn't capable of understanding simple English. Here, pseudocodes or flowcharts act as a bridge. But let's keep this topic for another video, shall we? Here is an example of how computational thinking works. Meet Kate. Kate is a student. Today, Kate has been assigned a history project to make and she is very tensed. But Kate is saved, since she knows how to think computationally. Kate knows, making a project is a lengthy task. She divides it into 3 tasks. Task 1. She can decide the topic for her project. It should be an interesting and attention attractor. Task 2. Searching information, she can take help from her textbook, library books and of course internet. And task 3 will be to compile all the information into a project. Now making a project doesn't seem such difficult, since she decomposed her problem into smaller tasks. Kate skims through her textbook and decides to make a project on World War. So, task 1 accomplished. Kate has earlier made a project of English on the effect of our history on modern literature. So, she knew where to find the history books in the library. Similarly, she is also aware of the websites she could find relevant information at, from her last project. Here, she used pattern recognition to track similarities in her experiences and make a new project. So, task 2. Accomplished. Kate strained the data she had gathered and finalized the information she had to put in the project, thereby using abstraction. Finally, Kate followed down steps of preparing a project. First introduction, then acknowledgement and index and finally the content. Then she decorated the pages and the cover file and finally, voila! Her project is ready. So, task 3 accomplished. Let's observe what Kate did. Kate used decomposition to divide her tasks. She used pattern recognition to find the content for her project. She used abstraction to finalize the content she had to put in the project. And finally she used algorithm to make the project. Now that we know what computational thinking is, let's just have a very quick recap to summarize everything. Computational thinking is all about formulating the solution to a problem in both man and machine-centered manner. This problem-solving method has 4 steps. Decomposition. That is breaking the problem into manageable chunks. Pattern recognition. That is finding similarities between present problem and earlier experiences. Abstraction. That is focusing only on important tasks and ignoring the rest. And finally algorithm, which is the steps to follow to solve the problems. Remember, algorithms are expressed in the form of flowcharts or pseudocodes. Hope you enjoyed the video. Now, it's time to bid you goodbye. But we will meet soon.